Hello, welcome back to the channel, and today I'm going to be looking through the Mathematics Numeracy paper, Unit 1 Non-Calculator Higher Tier from the WJEC that was set in May 2023. So as usual, we go through the front cover first. Pi is again taken to be 3.14. There were 11 questions totaling 80 marks. There's some information about what colour pens to use. So let's start the paper. As usual, we have the formula list. So we have area of a trapezium, volume of a prism, some volume and surface areas of spheres, volume and surface areas of cones, the sine, cosine, and area of the triangle calculations for non-right angled triangles, the quadratic equation, and the annual equivalent AER. So, question 1. So this is one of the OCWs, so you're assessed on the organisation, communication and accuracy in writing. So Mari and Hugh share a prize of £2,700 in a ratio of 4 to 5. Mari decides to donate 24% of her share of the prize to charity. Hugh decides to give the same amount of money as Mari to charity. What fraction of Hugh's share of the prize money does he give to charity? Express your answer in simplest form. Okay, so first of all, we're going to calculate how much Mari gets. So Mari won 4/9 of £2,700. So we can cancel with the 9 there to give 1, and we can cancel with the 27 here to give 3. So we end up with 4 times 300, which is £1,200 or £1,200. Next up, the charity amount. They get 24%, which is 24 over 100 of that £1,200. So again, we can cancel these two zeros with those two zeros, which gives us 12 times 24. So 24 can be written as 2 times 12. So 12 times 12 is 144. Therefore, 2 times 12 is £288. So now Hugh won 2,700 minus 1,200, so he won £1,500. And now we need to put this into a fraction. So charity fraction is equal to 288, because Hugh gives the same amount as Mari, over 1,500. So now we're looking for a number that can go into both of these. So my initial instinct is that this can be divided through by 3, so that will get rid of that 1, so we have 500 on the bottom. And if we divide the top by 3, that will give us 96. So we end up with 96 over 500. So both of these are divisible by 4. So I'm just going to write this down neatly down here. So I'm going to divide by 4. So 4 goes into 96 24 times, and 4 goes into 500. Well, 4 goes into 125 times. So it's 4 times. 4 goes into 125 times. So into 500, it goes 125 times. Now these numbers aren't divisible by 2, 4, or 6, or 8. So this is our final answer. So the final answer equals 24 over 125. So now we've got a picture of a map. The direct straight line distance between Llangollen and the Pont Chrysalit aqueduct, or Pontysillit aqueduct is 5.6 kilometres. On the map, the distance is 5.6 centimetres. What is your scale of the map? Circle your answer. Okay, so we need to convert centimetres to metres, so we times by 100, and then we need to convert metres to kilometres, which is times by another 1,000. So it's 1 to 100,000. So the aqueduct was built to carry the canal over a valley. The following facts about the section of canal over the aqueduct are found on the internet. It has a rectangular uniform cross section. It's 300 metres in length. It holds 1,500,000 litres of water, and it takes 2 hours to drain. The section of the canal over the aqueduct is to be drained. Calculate the number of litres of water that is drained from this section of the canal per minute. You may assume the water drains from the canal at a constant rate. You must show your workings. Okay, so we need to calculate litres per minute. So for this we have 2 hours is equal to 120 minutes. So what we're going to do is we're going to divide 1,500,000 by 120. So first of all, I'm going to cancel this 0 and this 0. So we've got how many 12s are in 15? That's 1. And there's going to be a remainder of 3. So we're going to bring that 0. How many 12s are now in 30? And there's 2 with a remainder of 6. How many 12s in 60? Well, there's 5. And then we're going to have a couple of zeros remaining. So it's going to be 12,500 litres per second. Oh, sorry, per minute. Calculate the area of the uniform canal cross section. Give your answer in centimetres squared. So again, we've got this 1,500,000 litres. So we need to convert that into centimetres. So to convert into centimetres cubed, we need to times by 1,000 because every litre is 1,000 centimetres cubed. So we got the original 1.5 million, and then we're going to add another couple of zeros or 3 zeros on the end to get this in centimetres cubed. We're told that the length of the canal is 300 metres, so we're going to convert that into centimetres by times it by 100. So we have 300,000, and now we're going to divide the top number by 300,000, so we can cancel those zeros there, those zeros there. So we end up with 15,000 divided by 3, which is equal to 5,000 centimetres squared. So a jar contains 300 grams of chocolate spread. In the spread is 58% of the mass is pure sugar, 1/8 of the mass is cocoa, and the mass of the milk powder is 4/5 the mass of cocoa. The remainder of the 300 grams is palm oil. Calculate the percentage of palm oil in the chocolate spread. Okay, so We know that 58% is sugar. We know that 1/8 is cocoa. So 1/8 is equal to 12.5%, and that's obtained by doing 8 divided by 100, which gives you 12.5%. We can also work this by knowing that a quarter is 25%, therefore an eighth is half of that, which is 12.8% or 12.5%. We now know that 4/5 of this 12 is cocoa. So if we find 4/5 of 12.5, then this is equal to, well, 4 times 12.5, well, 4 times 12 is 48. 4 times 0.5 is another 2, so that's going to give us 50 over 5, which equals to another 10%. So we now have 58 plus 12.5 plus 10. So that all totals to give you 70, 80, 80.5%. Therefore, palm oil is equal to 19.5%. A different jar contains 840 grams of chocolate spread. The label on the jar says offer includes 20% extra spread for free. How many grams of chocolate spread did the jar contain before the offer started? Right, so for this one, other than it's been badly worded, because I'm assuming before the offer started there would still be 840 grams in the jar, they just stuck a different label on it. But what they're actually asking is, what would a jar without the 20% extra free be? So for this, what we do is we take 20% and we can say that that's equal to 0.2. Because there's a value has been increased from a number up to 840, we can say that 1.2x, which is the value of the original jar, is equal to 840. So this means we have 1.2 divided by 840. So this will work out as, can you see that this is just 12 divided by 84, which is 7. But because we've moved the 0 and we've got an extra 0 on the end, this is the equivalent of 700. So the original jar would have been 700 grams. Okay, so Dava Design Services employs 60 people. Employers were asked to log onto the computer at 9 a.m. on a Thursday. The number of employees logged on was recorded every 10 seconds from 9 a.m. The results are displayed in the cumulative frequency diagram shown below. Use the cumulative frequency diagram to estimate the median time taken for the employees to log on. So the median is the middle person. There's 60 persons, so we're looking for the 30th person. So we're going to come across to this point and then we're going to come down to here. So it's actually 40 seconds. Dava Design Services has a policy that states 90% of employees should be logged onto their computer by 9:01 a.m. Show that this policy is met on Thursday. So we have to find 90% of the 60 people, which is equal to 90 over 100 times by 60. So we can cancel a 0 there, a 0 there, a 0 there. So we've got 9 times 6, so we're 54. So we're looking for the 54th person, which is going to be here on the graph, which is about 58 seconds. So the 54th person logged on in 58 seconds, which is the equivalent of 900.58, and therefore we have shown that they've 90% have logged on by 9:01. Alan Frames is a company that employs 360 people. 6 of these people were to be selected to discuss the changes to the company logo. The manager has decided to use a systematic sampling method. He has a numbered list of the 360 people. When using the systematic sampling, where should the list start, and where should the manager start his selection of 6 people? And we've got tick boxes, so we've got the 60th person, a randomly chosen name, the first person in the list, or the last person in the list, or a number that is multiplied by 60. So we actually go for a random person, or a randomly chosen name. The manager actually starts by selecting the 4th name on the list, so this actually answers the question above. Complete the table below and to give the position on the list of those who will be selected. Okay, so we divide 360 by 60, which gives us the 6 people. So other way around, 360 by 6 to give us 6 people. So we are looking to basically add 60 onto each of these. So we have the 64th, the 124th, the 184th, the 244th, and the 304th person. David works in a call centre. On Monday, he makes 200 calls. He's recorded the length of time spent on each call. David noted that the following about the time spent on the phone. The greatest time was 2 minutes 10. The range of times was 2 minutes. The median was 84 seconds. The upper quartile was 108 seconds. The interquartile was 68 seconds. And then they're basically asking us to plot a whisker diagram, box and whisker. So let's start off. Greatest time, 2 minutes 10, so that's equivalent of 130 seconds. So we can draw a line at 130. The range was 2 minutes, so that means the shortest amount of time was 10 seconds, because if the largest was 2 minutes 10, take 2 minutes off that. So we need to put another line here. The median was 84. So that's 90 there. So we're going up in 4s or in 2s, so it's there. The interquartile was 108, which is going to be there, which also means we can now join up our box. The interquartile range was 68, so this is our upper quartile minus the interquartile range will give us our lower quartile. So we got 108 minus 68, which is 40, so that's going to give us another line here, and there's our box and whisker. David had to complete half his phone calls in less than 1 minute and 30 seconds each. By how many seconds did David beat his target? Well, he answered half of them, which is the median line, in 84 seconds, so he beat it by 6 seconds. On Monday, how many of David's calls lasted less than 108 seconds? So this means the upper quartile is how he did 3/4 of his calls in that time, but he had 200 calls, so we got 3 times 3 over 4 times 200, so that can cancel to give 1, that will cancel to give 50, so we divide in 200 by 4, 3 times 50 is 150 calls. Okay. Cartons of soft drinks are filled by an automated system. Each carton is a cuboid that has a base of exactly 40 centimetres, a height of 30 centimetres correct to the nearest centimetre. Calculate the least possible volume. So this is the smallest carton we can get, and the smallest carton is when the height is minimum. So this means that our height can only ever be 12.5 nearest to the nearest centimetre. So we're going to have 40 times by 12.5. So I'm just going to do this as 125 times 4, which is 500 millilitres. Because I can move the decimal point, because I can times the 12.5 by 10 to give 125, and then because I've timed by 10, I can take the 10 off the 40 to relieve it with 4. Right, and empty cartons moving on a conveyor belt pass under a filling gun that pours soft drinks into the carton until they are full. Drinks are poured into each carton at 8,000 centimetres cubed per minute, correct to the nearest 1,000 centimetres cubed per minute. Calculate the greatest number of cartons that the automated system can fill in an hour. Ignore the time moving from one full carton to the next empty one. Okay, so for this we need the fastest fill-in rate, which is 8. I've just realised this one above should be centimetres cubed, not millilitres, which makes it a bit easier for this one. So the fastest rate we can have is 8,500 centimetres cubed per minute. And we're going to be filling the smallest carton, which is 500 centimetres cubed. So if we divide 8,500 by 500, we end up with 85 divided by 5, which is 17. So it can fill 17 cartons per minute. So we need to now do 60 times by 17. So I'm going to do 17 times by 10 is 170, times by 6. So we get a 0. 6 times 7 is 42. Carry the 4. So there is our answer. So it's 1,020 cartons per hour. Okay, so cartons of a different size are filled by using the same system. The cartons has a square base, a height of 20 centimetres. The volume is exactly 960 centimetres cubed. Calculate the length of the side of the base of the carton. So first of all, we need to find out what the area of the base is. So this is going to be equal to 960 divided by 20. So we can cancel those two zeros. 2 goes into 96 48 times. So the base is 48 centimetres squared. And because it's a square base, the length can be expressed as the square root of 48, which is a number just less than 7. But they want it in the form of a root b. So we can write this as 3 times 16, which is the same as doing the root of 16 times the root of 3. The root of 16 is 4, the root of 3 is root of 3, so we got 4 root 3, which is in the form they want. So to know this, you need to be able to recognise your square numbers, and that one of the square numbers, so either 4, 9, 16, 25, and so on, can be divisible by 48, which gives us the 16, and that allows this to be done simply. Question 8. Using the mass of an atom of hydrogen is that. The mass of an atom of oxygen is this. Use a suitable approximation and estimate how many atoms of hydrogen there are in 1,000 grams of hydrogen. Okay, so we're going to start off with 1,000 grams, and we're going to divide that by the mass of hydrogen. And trying to divide 1,000 by 1.7 is going to be tricky. So what I'm going to do is use my ability to do the approximation. So I'm going to write, first of all, 1,000 as 100 times 10 to the 3. So I put it into standard form. And I'm going to round that 1.7 up to 2. So this will leave me a half. So 1 divided by 2 is a half. So I'm going to write that as 0.5 times 10. And this, because we're dividing the same base, we can subtract the power. So I have 3 minus 27. So minus times a minus is a plus. So I've got 3 plus 24, which is going to give us 27. And then to convert this to standard form, I can write this as 5.0 times 10 to the 26 atoms. Which seems reasonable, because if you know your chemistry, Avogadro's constant, which is the number of atoms per mole, is to the order 23. 1 mole of hydrogen is 1 gram, so this should be 1,000 times bigger. Right, a mole of water consists of 2 atoms of hydrogen and 1 of oxygen. Calculate the mass of the water. Give your answer in standard form. So I'm going to need 2 times 1.7 times 10 to the minus 24, which is 3.4 times 10 to the minus 24. And I'm going to need to add that to 2.7 times 10 to the 23. So adding in standard form becomes easier if your base and power is the same. So I can write that as 27.0 times 10 to the minus 24, which means we end up with 30.4 when we add, times 10 to the minus 24. But in standard form, we like to have one number followed by a decimal. So this is 3.04 times 10 to the minus 23. And that should be of the same order of them as the mass of oxygen, because oxygen is far bigger than hydrogen. Question 9. Diod makes cocktail glasses out of thin glass. One of their cocktail glasses is shown below. A hollow hemisphere forms the part of the glass which is to hold the drink. Before each hemisphere is attached to the stem, the surface area of the outside of each hemisphere is given a decorative coating. The volume of each hemisphere is 1 128 pi over 3 centimeters cubed. Calculate the surface area that is given to decorative coating. Give your answer in terms of pi in its simplest form. Okay, so the surface area of a sphere, so surface area of sphere is equal to 4 pi r squared. This is given above in the formula sheet. So surface area of hemisphere is going to be equal to half that, which is 2 pi r squared. The problem is we don't have r, so this is where we need to use the volume. So volume of sphere is equal to 4 over 3 pi r cubed, which means volume of the hemisphere is 2 over 3 pi r cubed, which we know is 128 pi over 3. So this 3 will cancel with this 3, this pi will cancel with this pi, so we end up with r cubed is equal to 128 over 2, which is equal to 64. Therefore, r is equal to the cube root of 64, which is equal to 4, because 4 times 4 is 16, times another 4 is 64. So r is 4 centimetres. We can now plug that back in. So we got 2 pi 4 squared, which is 2 pi times 16, which is equal to 32 pi, and centimetres squared. So this company also makes another style of cocktail glasses in 2 different sizes. These glasses are mathematically similar. The ratio of the volume of the smaller glass, the volume of the larger glass is 8 to 27. The height of the larger glass is 18. Calculate the height of the smaller glass. Okay, so we've got this 8 to 27, which can be written as 8 over 27. So this is the volume scaling factor. We need to find the length scaling factor. So to go from a volume, because it's a three-dimensional shape, we need to cube root. So length factor is going to be the cube root of 8 over 27. Luckily, both of these are cubed numbers. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. And the cube root of 27 is 3. So this is why it's important to know your squared and cubed numbers and have them at hand so you can see these relationships. So now we just need to do 18 times by 2/3. So we can do this as 36 over 3, which is equal to 12 centimetres. So that's the height of the smaller glass. Okay, what we got here? So a train completes a 16,000 metre journey between 2 stations. Here is the description. The train accelerates at a uniform from rest to 20 metres per second in 40 seconds. It then remains at a constant speed of 20 metres per second for a period of time. The train then decelerates uniformly for 80 seconds until it has stopped. A sketch is shown below. Calculate the distance travelled in the first 40 seconds. So the area under the graph is the distance. So we got the area is equal to half the base times the height, because it's the area of this triangle in here. So we got a half of 40 times 20. So that's the equivalent of 800 halved, so that's 400 metres. Calculate the total time for this journey. Okay, so we've got here another line that goes down here, and this length here is 80. So if you notice, we've got the area of a trapezium. So the area of a trapezium, if you look on the front of the page, is area of, I'll just draw a trapezium, is equal to half a plus b times the height. So if we substitute this in, so we got this distance here, which we don't know, which is x, which happens to be the same distance along the top. So we've got a half x plus this bottom part, which is 40 plus x plus 80, times the height, which is going to be 20. So we can simplify this. So this 2 is going to cancel with this 2 to give 10. Inside the bracket, we're going to have 2x plus 120, all times by 10, and this is all equal to the total distance, which is 16,000. So we have 20x plus 1,200 is equal to 1,600. So if we take the 1,200 over to the other side, that will give us 14,800. So x is equal to 14,800 divided by 20. So that will cancel with that. So we end up with 2 into 14,800. So it's going to go 7 times into 14. Into 8 it goes 4. So 740 seconds. And then total time, which I'm just going to have to write down here, is going to be equal to 740 plus 80 plus 40, which is equal to 860 seconds. Oh, there we go. We could add more space below, so we could have done that down there. When the train begins its next journey, it accelerates uniformly at that 1.81 recurring. Write the acceleration as a mixed number in its simplest form. So the way I like to do this is say that x is equal to 0.08181. I'm going to multiply this by 1,000, say. So I'm going to do 1,000